Hello and welcome to the third part of this tutorial. On parts 1 and 2, we saw how to create a 2D frame structure and how to incorporate plastic hinges, moments, rotation plastic hinges, which we modeled as link elements. Now we're going to obtain some results from this analysis. First of all, we're going to make sure that we are on the post-processing module. We're going to navigate to File, Open. We're going to locate our results portal file, and we're going to open it. We see how the structure is swaying, it's reacting to the displacement that we are applying at the top. So with these buttons, we can go to time 0. We plot the loads, and we see how at the beginning we have a only applied vertical loads. And then if we skip time steps to the right, we see that this arrow, the prescribed displacement, becomes increasingly large and the structure reacts accordingly. So we're going to switch off the load plots and the undeformed shape. We're going to leave the deformed shape of the structure and the nodes. And there is two result types that I will want to obtain. One is a graph that compares the reaction, the base shear force to the horizontal displacement at the top left of the structure. That will be one graph. And another graph will be from one link element, for instance, this particular moment hinge in here. We're going to obtain a moment rotation curve. So let's start with the base shear to displacement. We're going to need a definition model point combination because we want to sum the reaction at these two base nodes. We're going to add support nodes, double click on the blue field, select those two nodes, right click and finish. And we're going to apply a weighting factor of 1, but we're going to reverse the sign because if we push the structure to the right, the reactions will go to the left, but we want to have positive values of this base shear. So we click OK. And then we need another definition for the displacement of that corner node. So we're going to model point node. We're going to add a top corner, click on the P button, select that node and click OK. Right, so we're going to navigate now to graph, response curve. We're going to have the top corner X displacement on the horizontal, on the X coordinates of the graph, on the X axis. And we're going to have, for the support nodes, the X reaction. We could have, in a different scenario, we could have used the sum of the reactions. We didn't because we are applying a horizontal displacement in here. If this was a force, then we would have an equal force pushing to the left. However, in this case, because we're applying a displacement, the sum of all reactions would be 0. So we want the reactions only at the base of the structure. So with those selected, we click OK. And this is how the base shear evolves as we continue to apply the push towards the right, this displacement to the top corner of the structure. When the hinges start to go plastic, we see how the base shear is going down, which is expected. So I'm going to get rid of that graph by clicking on it and pressing the delete key on the keyboard. And now we're going to create the moment rotation curve for one link element. So we're going to go to definitions, model point, and we need element section for link element results in general. We're going to add a moment connection. Let me display the element labels. So we will select, we will identify this is the 119 and belongs to element group 4. So it's element group 4, element number 119. and we just need to have here label 1 and click OK. So we are now ready to graph the moment rotation. So we navigate to graph, response curve. We have the moment connection here, model points. We want displacement. Remember that the link elements have a local RST axis system. So the T rotation, we said T is aligned with the global Z. So we want T rotation and we want the bending moment in T as well. So we click OK, and this is the graph we get going plastic, and then, well, it has this shape which is pretty much the same as the one on primer example 72. And lastly, we're going to show how to export these data sets into a, well, either a TXT or CSV format. So we can do this in different ways. One way would be to navigate to list, value list, model points, because we want to export model point data sets. For instance, we're going to select our moment connection results. The first data set is going to be the displacement rotation that we have here on the horizontal axis. And the second data set is going to be force bending moment in T, which we can, well, if we click apply, we're going to see our data sets printed down here. And we can export as a table. This is data that we could readily copy and paste onto a spreadsheet, or we can, of course, export, in which case we can, well, export a file as TXT or a CSV format. If we cancel here, we have another approach, which consists of coming here to graph. We navigate the way down to list, and this is going to, again, print all the values in the existing data sets on the particular graph that we have here selected. And we could, again, export this data set to a TXT format. Well, this concludes this tutorial. I hope you found that helpful. Thank you very much for watching.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.